Quick video on probability, and this is without replacements, just looking at a few different types of questions, hopefully just answering a few questions along the way. Firstly, key points, probability without replacement. It basically means when we draw one item, then we're not going to replace it back before drawing the second one. So it might be the case that you've got 6 marbles, which we're going to look at the moment, and then it's going to drop down by 1 marble. But not only does the total drop down because you've got 1 less marble in your bag, also that set colour that you picked before has now gone. So we'll see that now just in an example. So this is the example. We got Mason, and he's taking a marble from the bag and then he does not put it back. And it should tell you there that he's not going to put it back. So when we see a question like this, first thing we're going to do is work out how many marbles have we got in total. So we've got 6 marbles and, well, 4, so that gives us 10 marbles. So the first things are going to be out of 10. And then he's got 6 red and 4 green. Now, if he chooses a red marble, well, first of all, we know if he chooses any marble, the marble's now going to drop down by 1 because we're taking a marble away. So if in doubt, you could just write these in straight away. Now, he's chosen a red. That's what it means when you choose the red line. So that needs to drop by 1. Greens are going to stay the same because they haven't been chosen yet. So that's why the 4 is still there. Now, if we go to the green marble, so we're going down that line, that means he hasn't taken a red one. That's why it stays the same. And then he has taken a green one, so it drops. You should notice that each of those branches are still going to add up to 1. If they don't add up to 1, then that's where you've gone wrong. Okay, the next bit is work out the probability that Mason takes 2 marbles of the same colour. Well, if he takes it of the same colour, it's going to be red and red, which is 6 over 10 times 5 over 9, which gives us 30 over 90. And it's going to be green and green, which is 4 over 10 times 3 over 9, which gives us 12 over 90. Okay, so then we can just add those together once we're done, which gives us 42 over 90. Now, you can simplify that, but there isn't asking for any simplifying, so I would just leave it like that at that point, because you do have an element of time that you've got to allocate for this question. Next question. Here are 7 number cards. Helen takes a card at random. She does not replace the card. She picks up another card at random, and we've got to calculate the probability that both cards have the same number on it. Okay, so let's look. How many cards we got first? We've got 1, 2, 3, 4, 5, 6, 7. So I've got 7 different cards. And if I just go through the numbers, so probability of 1, 1. So choosing 1 twice. So the first time the probability of 1 is 2 over 7. And then the second time of that happening is going to be 1 over 6, because there's going to be 1 less card. The probability of 2, 2. Well, again, it's going to be 2 over 7 times 1 over 6. And the probability of 3, 3 is going to be 3 over 7 times 2 over 6. So we can work those out now separately. So 2 over 42, 2 over 42, and 6 over 42. So that gives us a final probability of 10 over 42 chance that they're going to have the same number on them twice. Similar to the first question, so it says calculate the probability the number on the second card Helen takes is greater than the number on the first card she takes. Well, there's only 2 chances of that happening. So the probability of 1, then a 2, and then the probability of a 2 than a 3. So the probability of a 1 happening is 2 out of 7. Now on the second card, remember there's 1 card less, and that's still going to be 2, but this time out of 6. And then doing the same again, so 2 out of 7 to get a 2, and then 3 out of 6 for that last bit. So 4 over 42 and 6 over 42. Surprisingly enough, they have given us the same result. Doesn't make sense, but it does. So 10 over 42, just coincidence. Last question. So here are 8 cards, the numbers on each card. Erin puts the 8 cards in the bag. She takes a card from random and she doesn't replace it. She then takes the second card from the bag, and then we basically need to calculate the probability that the number on the second card is double the number on the first card. Okay, so if we have probability and we have a 2, that means she has to have a 4 on a second go. If she has the probability of a 3, she has to have a 6 on the second go. That's it, because we can't go any further, because if we went to 4, we need an 8, and we haven't got a card that has 8 on it. So firstly, to grab a 2, it's going to be 1 over 8. Remember, the cards are now going to drop because there's 1 less. We've got 2 4s, so it's going to be 2 over 7. And then doing the same, so there's 1 2 3s, so 2 over 8. And then for 6, let's go to it, we've got 1 2 3, so 3 over 7. And then we just work those out. So 2 over 56 and 6 over 56, which gives us a total of 8 over 56. Again, you don't have to simplify because it hasn't asked for it, but if you did want to, it's 1 over 7 chance. And there you go. I hope that helped.